So in last class, we have seen state, nodes, and edges. Okay, and just giving a recap of all the things. Okay, so uh, state is, what is state? State is shared memory which can be accessed by all the nodes. Okay, so state is like a container. Okay, so let's say in this container, the value are stored in key value form or in dictionary format. In dictionary format. Okay, so let's say maybe let's say name can be one key and its value. Similarly, age can be one value and one key and its value. So this dictionary we make with the help of either using Pydantic or TypedDict. Okay, and these values. So when we create a node, so let's say how we represent node. Node is represented by some circle, and this is a there will be some name. Okay, let's say function A. It is basically node, right? So node is nothing but function. Node is function. Okay, and in node, so when we create a graph, and in graph, let's say if there are 3 nodes, so all nodes input will be state. Okay, so all nodes input will be state, and so if I talk about, let's say this is node A, so there will be some state. For example, let's say in this state we defined, let's say there are 2, name, age, and let's say count. Okay, and let's say we define some value. So let's say this node A increase the count. Okay, so node basically, the function of node is to partially or fully update the state. Okay, so let's say in this node A, we write some function which can increase the count. So the output of this node A again will be name, age, and count. But count, let's say it increased by 1. So now count is updated with new value. Name and age can be remain the same value. Okay, so any function or any node input will be state and output will also be state, but that will be a updated state. Okay, and state is nothing but a container which contain multiple variables in key value format. Okay, okay, so now in today's class we will see basically just a second. Okay, thanks. So we will see different type of workflow. Okay, different types of workflow. Workflow is nothing but, let's say when you create any flow diagram, so it is like that only. Okay, and so in workflow, there are nodes, and let's say there are two nodes. Okay, node A, node B. So when we join these two, so these are called edges.
Edges.
Okay. Yeah. Now, so let's say let's see the first workflow, that is a sequential workflow. Okay. In sequential workflow, so there will be some start node. So that is for this you don't have to write function. This function is already provided by LangGraph. Okay, so let's say there is a start node, and after that, let's say there is some other node. Let's say node A. So node A will have some function. Similarly, let's say node B, and then let's say end. Okay, so here all the things happening sequentially. Okay, so in this flow diagram, if you see, so the flow is like from top to bottom.
Bottom.
Okay, and there is no parallel thing. So this is called sequential workflow. Okay, um, now similarly there is other called parallel workflow. Okay, so in parallel workflow, so again it will have some start thing, and then let's say uh, node A, node B. Please allow if anyone coming. Okay, um, so node C, uh, then just, and then there will be a end. Yeah, so this is a parallel workflow. Node A, node B, node C, all are means there is a start thing, and then all three node A, node B, node C running parallelly, and then program will end. Okay, so this is a parallel workflow. uh, there is one more, not just one more, there are other as well, but now this is let's say there is a start, which is combination of sequential and parallel. So let's say we start with this is a node A and node B, and let's say here you merge node C. Okay, you are not ending, you are merging the output of node A and node B into node C, and then there is a end. Okay, so it is here it is a parallel, it is combination of parallel plus sequential. Okay, um, so this is a mix of parallel plus sequential.
Sequential.
Didi,
uh,
hello.
uh, Please mute means I think
Oh,
Adit
sorry, sir.
voice is coming. Yeah.
Sorry, sir. Sorry, sir. Sorry.
Yeah. Then next is conditional workflow. Okay, conditional workflow. So let's say again in everyone start will be there. Then let's say node A, node B, node C. Okay, and node D. End. Okay. So here the conditional are represented by dotted. So let's say this is a dot dot. Okay, or dash line. Yeah. Okay. So here this is a conditional. So conditional is, let's say we start thing, and based on some condition, either it will go to node A, node B, or node C. So in any graph where you see this uh, dash dash line, okay, or broken line, then that is basically a conditional edge. Okay. So the solid line is, okay, the connection is means from node A to node D, that is sure shot. Okay, means there is no condition. But from start to node A, or start to node B, or start to node C, if there is a dash line, basically that is
Conditional.
representing the conditional. Okay, and this we also call it as a conditional edge. Okay, and you can make means these are just 3 4 different types of workflow, but apart from this also you can make any workflow. Okay, so we will see how to create this workflow in LangGraph. Okay, let's see through code. So I already created. Okay, so let's clear all our code. So all this, first you have to import different thing from or different libraries from LangGraph and Pydantic or TypedDict. Okay, and so first one is basically for creating a schema, TypedDict. We are using TypedDict. Okay. Second one is LangGraph. So from LangGraph documentation, we will get all those things. So LangGraph.graph import state graph start end. So start is nothing. Start node and end node. And this is add message memory saver. Right now it is not required, but I have imported. And this is for LLM. LangChain OpenAI, Chat OpenAI, human AI message, system message, base message. Okay. So base message is in LangChain there are different types of message. So base message include all types of message. Okay. Just as okay. So let's run this first. Then this. Okay. So in last class we have seen how to create a schema, right? Or how to define a state. So let's say this is a to define a state, simply you need to write a class. Maybe I can. Okay. Let's. Okay. Hmm. Okay. So define a means, let's say if you have to define a state. Okay. So let's say you want to define some state of personal info. Okay. Personal info. So to define a state, first you need to write class, then the state name. Here the state name we are defining, or it assume it as a container name. Okay, so the box name where you are putting the value. Okay, so here the box name is personal info, and inside that just use TypedDict. Okay, so this TypedDict we are importing it here. Okay, TypedDict. Now here you have to write what are the things that you want to store. Okay, so this is a, let's say, name. So name is a key, and you also need to define in which format you want, or which what will be its data type. So name will be string, right? Then age will be integer, Okay, let's say sorry, then email id. Email id is also a string.
string.
Okay, contact number. Okay, contact number will
Int.
also be int. Okay, so let's say this is how you can,
Uh,
you have define a box. Okay, again let's say, so by creating a state, what you have defined, name, age, uh, contact number, and email id.
email.
Okay, so so i- when you create a state, as I said, you are creating one container where you are storing these four values. Okay, and the container name we have given personal info. Okay, personal info. So to access any value, you have to use this personal info container. Okay, so all the nodes will use this container to access the value. Okay, from this container only they will get name, age, control, contact number, email id. And so let's say, initially let's say we put some values. Okay, for name also we put some value, age, so let's say name we put Suraj. Okay, then age 32, then contact number something 8294, blah blah. Okay, email id Suraj something. Okay, so let's say the initially you stored something. Now, and this is the most difficult part to understand is state. Okay, and when you creating agentic AI using LangGraph, the most difficult part is to understand state. Okay, so if you understand step, it will be very easy to create any uh, workflow. Okay, or agentic AI application. Yeah, so now let's say this is you have created, initially you put some values. Okay, and I will tell you how to put this value. um, so when you create a schema, or when you create a state schema, you are not putting any value, you are just giving the type. Okay, now let's say if you pass this to some node, yeah. So let's say you pass this container to some node A. Okay, and let's say node A have you have written some function where you can update this value. Okay, so node A can change this container values. Okay, node A node A has, or node has capability to change all value, all values, or some values. Okay, what node cannot do, it will not add any extra information in this container. Okay, any extra information in the sense, here right now name is contact number and email id, so it node cannot add, let's say, um, company name. Okay, so node cannot do that thing. So node can only add, change the value, not the key. Here name, age, contact number, and email id are keys, not values. Okay, so node can only change some of the keys, some of the values, or all the values, but it cannot change the keys. Okay, so first step while creating a agentic AI using LangGraph, to create a state schema. Okay, so this is called, a state schema. Okay, and here you are defining the container, that this container contain name, age, email id, and contact number. Okay, and you define what will be its type. Okay, so name will be string, age. Okay, now, so this is how you can create a state. Now the next thing is to define a node. Okay, so let's say I am just So let's say, okay, so here when you create any, okay, so let's say I define function name is node A. Okay, you define any, you can write any name, not a problem. In that, the first thing will be state. Okay, first thing will be state, and its type will be personal info. Okay, personal. Just copy this thing. In any function, this the input is fixed. Okay, yeah, personal info, and we have seen in type printing how to basically just forget the, okay, yeah. So state is an input, its type will be personal info, output type will be dict. So output, it will provide dictionary because this is dictionary. So output, it will provide in a dictionary format. Okay. Now let's say node A just um, okay, return. Let's say based on this value, I want to write some sentence. Okay. So let's say I write name equal to access the name. So this is like a dictionary, right? So to access the name, what should I write? State of name, right? Uh, do not confuse with this one. Okay, name and then age of A. What I can write? State of
H.
age. Okay, and let's say I use these two value only. Okay, I don't have I do not require to use all the value from this container. Okay, so I am just using name and age, and I am returning uh, mm, oh, just add one more message. Okay, str. So returning key state of message. Message equal to here the name is name underscore A, and age is cannot assign. Okay, yeah. So you are returning. Uh, you're just updating the message thing. Okay, and let's say if you want to update multiple things, you can add again name equal name. Let's say if you want to add some new name. Okay, so here name you can write maybe Raghav. Okay, yeah. So this is how you can, here we are creating a one function. This is called node A, which take state will be input. Okay, and here we are just accessing the name and age value, and we are returning two things. So we are changing message thing. Okay, and we are also changing the name value. So the name now changed to this one. Okay, so this is how you can create a node. So in this example, if you see, there are, so this is a schema, and this is how you created first node, then second node, and so these two nodes you have created. And builder dot first step will be to just, when you creating a graph, just you write state graph state. Okay, state graph state. So this is a basically state you are inputting. Then builder dot add node. Maybe what we can do, I think it will be better to create our, okay, so this is a node A. Okay, let's say we define some node B as well, and let's say node B, node C. So in, let's say in node B, we are just providing contact of A, contact number, then email ID. Okay, email underscore ID. Oh, email ID. And okay, so the here the contact number is, and age is this one. Sorry, email ID is this one. Okay, and here let's, we are just changing only one value. So we are just changing the message. Okay, now, so let's say these are the two nodes we have created. Okay, so first node, what does first node do? So it's just returning, okay, the name is this one and age is this. Okay, and the second node basically the contact number is this one and email ID is this one. Okay. So first step will be just copy this thing. So here we have defined state, then node, then next step will be just to so here builder, instead of you can write anything, it is not required. The variable name you can change, but this builder equal to state graph. Okay, and state graph we have where this have already we imported from LangGraph. Okay, now inside state graph what we need to input, so our state name is or schema name is personal info. So here you need to input the personal info. Okay, now and let's say first I write first graph. Okay, now so first we define, so first step is personal state schema, then node creation, then from here we start creating a graph. Okay, so in graph when you creating a graph, so first step will be this thing you need to call. So this is state graph and inside that the schema. Now after that you have to add node. First maybe I put some simple name. Okay, graph dot add node. I think here this, yeah, add node, and here fgraph dot add node. So in that there will be two inputs. So first input will be name of the node. Okay, so let's say I am writing node. Yeah, simply I'm writing A. Okay, and which function I'm associating, that I need to write. So I'm associating node A. So this is the function name, and the node name, the circle that we create, that name is A. I have written. Then again, we have created two functions. Uh, so I need to add second one as well. Okay. So here B and this node B. Okay. So these two things get created. Now we have to define the edge. Okay. So we have make the circle now to connect the circle. Okay, so to define the edge, yeah, let's start with the edge creation. Okay, so here simply f graph dot edge. So first thing will be start. Let's say from start I want to go to node A first. Okay, so here we have to write the name. So this is the name that we have given. Okay, yeah, then in second step will be, let's say I have to go to from node A to node B. Just, yeah, so what I want to create in this way: start, then I want to go to A, sorry, yeah, A, then I want to go to B, and from B I want to end. Okay, so first edge will be start to A, second edge will be A to B, third edge will be B to end. Okay, so first edge we have already created, start to A. Second edge will be A to B. A, and from A to B we want to connect. And one more edge is there, that is B to end. B, and from there you want to end, right? So this start, sorry, this start and end thing we have imported from LangGraph. Okay, start and end. So these are by default node. Okay, so now you have created edge, you have created circle. So this adding node will create circle, that A and B. Start and end circle is already created by LangGraph. Now the next thing is to compile. Okay, so here compile means just you are giving the final. Yeah. So you have given graph, and here you have graph dot compile. Okay, and let's say I want to see the picture of that as well. Okay, to see the pictorial representation of your graph, so what you can write this way. Okay, so let's say we run this thing. It will take some time to create a graph. Okay, so this is how you have created start, then A, then B, then end. Okay, so now your software is ready. So assume this is as a software. Now you need to provide input. Okay, and what are the input? Name, age, email ID, contact number, and message. Okay, so you have to provide input. Um, let's provide input. Okay, and let's say here what are the input that we need to provide? Name, age, email ID. Let's copy this thing. Okay, let's say name, and let's, I'm putting it as a empty. Okay, so all this thing, all the input you have to provide inside a dictionary. Okay, then age you need to give. Okay, so let's say age is 24. Okay, and name also, let's say name, maybe we can give some uh, Hitesh. Okay. And name is, the next thing is uh, email ID, and email ID is, let's say ABC @xyz. So this is email ID, then contact number, and let's say this okay. Then last is message. Message and message, let's keep it blank. Okay, so let's say here one more thing. Message 1 equal to state of message. Okay, and here I write message 1 plus. Okay, again I need to recompile the whole thing. Okay, now so here we have defined two nodes. So first node is just using name and age thing. Okay, and in message what it written, the name is this thing, and uh, let's okay. Huh. So let's run this. Okay, now let's see the result. Okay, so name Ragwa, age 24, email ID this one, contact number this one, and message the name is Hitesh and age is 24, the contact number is and email ID. Okay, so the output is just a state, right? In our state what we have defined, or the output will be container. Okay, so in that container what we have defined, name is email ID, contact number and message. So if you see from this output, initially we have given name Hitesh, right? And what we have done here, so it will go to first node A, right? It was gone to first node A. In node A, what are the value that we are using? Name and age, right? And it was returning, it just updating the message and name thing. Okay, it just updating the value message and name. These two key it was updating. So in name we have updated with the new value that is called Ragwa. Okay, so it override the previous value. Okay, and so in message we have put this thing, the name is this one, and in name we have put this thing. Okay, in second step, so if you see the first step, it will change the update the value of name and message. Okay, so now the name is Ragwa and message is the name is uh, Hitesh and the age is 24. Okay, now in the second one I'm using the uh, previous state output. The previous state output in message was the name is Raghu, Hitesh and the age is 24. Okay, I'm just adding that to this message value, and here just adding extra information. The contact number is this one and email ID is this one. So in this way only I'm updating the message value. Okay, so because of that only you are getting the output, the name is Hitesh and age is okay. So this is how you can create a workflow, and this is how you can run it. Okay, so yeah, so this is a one of the simple example. Okay, and here also we are doing the same thing but different example. Okay, I'm not okay now. So sequential chain we have already seen, right? Now the thing that we have done was sequential. Okay. Yeah. Let me show this. Yeah. So this is an example of conditional. Okay. So from start, there is a categorized node, and categorized node will either go to general handler, math handler, or science handler. Okay. And if you see, these are dotted line, right? So this dotted line, as I said earlier, this is basically representing the conditional edge. Okay. Now in this also, let's say if you have to create some conditional edge. Okay. So here also first we have to define a state or container. So here the container name is routing state, and in that three values it is storing question, category, and answer. Okay. Now the next step is to define the node. So here there are total how many functions? Four functions are there. Okay. Categorize, handle match, handle science, handle general. Okay. So these are the four functions. And here also you will see categorize, general handle, math handler, science handler. So for each function there will be a single node. Okay. So total four node will be there. Okay. Now if you see the first function, that categorize, so the input again you have to write the function name, then state, then the container name as an input, then dictionary. Okay. So here we are just using given a prompt, categorize this question as a math, science, or general. Okay. So here the idea is like, let's say uh, we want to categorize the question. Let's say user is asking something, or let's say we are creating some chatbot where you want to categorize the question, and based on, let's say, um, user asks something, okay, what is science? So I will categorize that question into a science handler, and so this question will route it to science handler, and this will answer that question. Okay, so let's say there are three expert, and there is one expert called categorize, which basically categorize the input question and pass it to the suitable expert. So either to pass it to math or general or science. Okay, so we have three expert: science, math, and general. And categorize will basically categorize the question. Means its job will be either to route that question to science, math, or general based on, and this thing we are doing it by using LLM. Okay, so here we have write the prompt, categorize this question as a math, science, or general, and the question will we will exit it is it through from container. Okay, so we are just given question state of question. Okay, so this will basically, this is how you can access the question. And in response we have simply response llm dot invoke, and we are just giving this thing. Okay, in category response dot content dot strip, that is okay. My main focus is let's say if it gives some category, and we here we are updating which thing out of the three keys: question, category, and answer. We are just updating the category thing. Okay, now so here category equal to the category that it gives, and then we have create some simple function like handle math, return answer app, math specialist handling state question, science. We just write some dummy functions. Okay, it's not doing something, we are just returning okay whether that is categorize is working fine or not. Okay, now And also we have routes, created some routing function. Okay. So based on what logic that will go to particular node, or so here we have just created a function route question. So in this also state will be routing state. Okay. And we will see just what is the category. So we will see, okay, category, state of category. If math is the category, then it will return math handler. If science is the category, then it will return science handler, and else general handler. Okay. So, and all these things are nothing but node name. Okay. Node name. So this route question will return the node name. Okay. Now that is okay. Huh. So first step, let's say we have created builder state graph routing step. Okay. Now first step will be to add all the node. Okay. So here there are total 4 node. Okay. Don't consider this as a node. This is routing logic. Okay. So builder dot add node. So first we name it as a categorize handle math function. We name it as a math handler, handle science handler. So this all node we have created. Let's say first let's okay first see only the proper edges. Okay. Or the solid edges. The solid edges are general handler to end, science handler to end, math handler to end, and start to categorize. Right? These are solid line. There is no break. So first we create, let's say we create builder dot add edge. So start to categorize, then math handler to end, science handler to end, general handler to end. So here we have defined. Now the thing is this thing, right? This dotted line, how to create the conditional edge. Okay. So to add the conditional edge, builder dot add conditional edge. So this is how you can create a conditional edge. And in this, the first thing is from where the conditional edge started. So here it is starting from categorize. Okay. And now the next thing is based on what logic it will categorize. So here route question we are giving, this route question that we have made, that is basically the logic, and it is returning one of the 3 handler. Okay, either general handler, math handler, science handler. Its output will be one of the 3 name, math handler, science handler, or general handler. So here we have just written the logic. Okay, based on, so here we, and the logic is like based on the category name, we are either passing it to the math handler, science handler, or general handler. Okay. So here first we write the from where it is start and what are the 3 means in route question, what are the possible options of route questions. Okay, math handler, science handler, general handler that we have passes. Okay, so this is how you have created this thing. Okay, so you can run it again. Okay, so that is get created. One more thing here, order doesn't matter. You can write in any order. Okay, so it is not like that, but that is good if you write in sequential manner. Okay, now let's say here routing we have compiled it and this software is ready. Now we can give input. Okay, now let's say we ask, so we are there are 3 handler. Okay, so let's say first what is uh, new Newton's third law. It will not provide the answer. It will just give the category because here the LLM we are using just to The prompt is, or the instruction is, categorize this question as math, science, or general. Okay. Now, so let's run it. Okay. So here it is giving category science. Okay. So let's see the result. So in result, it is giving, the question is this one, category it giving science, answer it is giving by this thing. Okay. The answer is, the answer thing updated by this different functions. Okay. So answer is just returning, okay, science specialist handling this question. Okay. So this is how you can update the, this is how you can create a conditional edge and update the state. Okay. Till now, any doubt? If you understand this, then it will be super easy to create a workflow. Okay. Means the base will be ready. Only one thing that is remaining is a tools. Then we can start creating a application. Sorry, tools and um, check pointer. But yeah, this is also a super important steps. Um, so any doubt
Sir,
till this point? Yeah.
yes, sir.
So,
Sir, how the order of these notes
Uh,
here categorize is first ordered, then after this these three.
uh-huh.
Yes, sir. So how to give them the order?
So it depend on you, na? Means let's say you have to harvest a, let's
No,
say,
sir. I mean to say, how do we do it? I mean, using what library and all?
what library means, I'm not
I
getting.
mean,
Here only we are defining the order, na? We have to define the order, not library will define, right? Here we have written the
so it
code
will,
to,
so in the sequence which we will write it will define the order, right?
which sequence you are talking about. Means whether builder dot add node first, then categorize and categorize. This thing you are talking about, or whether the, let's say, this thing, let's say if I write math handler first, this you want, this you are
Yes,
talking
yes,
about? No,
yes, sir.
this doesn't depend on that. You can write in any order, but it will depend only on, uh, let's say you are creating a edge, na? So
Yes, sir.
the edge, it depend on the edge, how you are creating the edge. So you are creating the edge from start. So first, any graph will start from start only, right?
Yes.
And start to which edge you are defining, categorize. So it goes to categorize thing. Then in the second, math handler to end, math handler to end. So you are defining the, based on the how you are defining the edge, the order will depend.
Okay, okay, got it, sir.
Okay.
And sir, also in the starting there was one thing like F graph. What is that, sir?
App graph is just a variable name, na? Variable
Okay,
name
it
you
is just
can write anything, na? Variable name doesn't have any meaning. Means
yes,
in terms of functionality,
yes,
you are just creating a name, and name you can write anything. It is not like F graph is a, see the left side
yes, sir.
before, after equal to, there is a left side and right side. So left side has only, it is a representation. It doesn't do have any functionality. Only right side
Okay,
thing have functionality, right? So you
yes.
can name F graph, B graph, any graph you can write. Okay.
Okay, sir. Thank you, sir.
Huh. Huh.
so like basically, we are using a concept of like we can say that it's inheritance concept. Like we are calling the class, like in the like multiple inheritance like that. Basically, the concept behind this LangGraph.
Uh, mm, Multiple inheritance.
Like inheritance concept, like we are calling the, if we are creating a state, it's a class.
Mhm.
Like if we example, if we consider a state as a class, so let us consider it's a parent class, and we are calling that class in this functions, like what are functions we need, like node.
Yes, but in this class only, let's say TypedDict is a parent class, right? Uh,
Okay.
and you are calling that to just do not means see in that lens. Okay. Otherwise, it makes some confusion. Better to treat it as a schema only. Okay.
Okay.
Just assume that okay, this is how we are defining the schema, and because you have to follow this thing only, do not apply any extra
Okay.
sense on that, because it will create confusion only. So
Okay.
just
Okay.
treat it as a this is means just treat it as a syntax to create a container. Okay.
So
Yeah.
it's like if we like as of now we are considered two, but if in real time problem we have multiple like schema could be very big. Like we can create a multiple data. Like it will be a big data. So then how to handle with it? Like if we can give like we can call something like if we having schema from we want to draw something like we have to extract schema or what like schema should be written by us or we can extract from if for example if we uploaded a pdf we
Mhm.
have to create a schema from that pdf. So as usual we will use previous what we used before and then we will add this concept to there like you got my
So
point, right?
let's say if you have to create a means from any document, you have to basically the idea is like your idea is like to from any PDF extract the
Like,
text, but that
let us
in
take previous
particular
example. Yeah, let us take previous example. Like previously, we have used example like Pydantic, and we have uploaded a medical document, and we have extracted a schema from that.
right.
So yeah, so from that, if we can input that schema to the state like what we are creating now, and we can create multiple nodes like whatever the information we need, we can do from that.
Right. So let's say
Okay.
in any application you want to create a multiple steps. Okay. It is not a, just a single task you are doing. There are other tasks, but one task is dependent on other task. Okay. So in that scenario, it is better to create a graph. It is not always mandatory to create a graph. The same thing you can do it using LangChain also, right? Uh,
Okay.
but here the thing is like right now we haven't added tools and check pointer. Once we add all that thing as well, then we will see the power of this graph. Okay. And
Okay.
let's say if you talk about N8N or any agentic framework, there also you are creating a graph only, right? Means
Yes.
uh, the picture where it's so in that also you are creating this graph only, right? There will be some start button categorize
Yeah.
and
Start button agent will be there. Memory will be
but
added, and multiple
huh,
agents will be there.
right, but there these blocks are drag and drop, right?
Yes. Yes. Uh,
You are not creating a function for that, but here in LangGraph you are creating the function and you are connecting the edges through code. So you know what are the thing that is written inside the function. So if any error comes, you know where to make the correction or make the changes. So that is how, because of that reason only, in industry people are mainly uh, means looking for expert in LangGraph, not in any other agentic AI framework. Definitely some companies are using, but let's say if they are making some robust application, okay, or robust agentic AI framework application, there you will need a LangGraph. And
okay.
because of
Okay.
that reason only LangGraph is most popular library. Okay. Yeah. So here because you know what are the thing that is written inside a function, how you are connecting the edges, the workflow, how you can create different types of workflow. Okay. So you'll get the answer once we will move further and we add some extra functionality. But assume assume this as a just you are creating a container. And yeah, it is confusing that you are creating a schema for getting the structured output, and here you are creating the schema for getting the container, right? uh, yeah, it is confusing, but it is powerful way of basically updating the step. uh, the idea of means in LangGraph, what I feel is like they want to make it simple yet very powerful. Okay, you may not right now appreciate the powerful means it looks very simple, but once we add some more thing, and once you try different agentic AI framework, okay, means definitely if you have to create very simple framework or simple agentic AI application, you can use N8N or any Crew for AI, and there are other as well. You can use anyone, uh, but if you have to create very powerful and much controllable agentic AI, then LangGraph is the best one. Yeah. Any other question?
So Crew AI also same or it is different?
Crew for AI, all are agentic AI framework. Okay. Um, so Crew for AI is a Crew for AI, Google ADK, AutoGen. There are means I there are around more than 100, I can say, the
Yes, yes.
framework. Okay. So do not miss the idea, or the concept will be almost same. Okay, if you know one of the agentic AI framework, then it will be super easy to understand other. And
Okay,
if you understand LangGraph, then it will be much easier to understand Crew for AI or ADK or any other uh, agentic AI framework. But let's say the reverse is not true. If you understand Crew for AI, it is not easy to understand LangGraph.
okay.
Okay. Yeah. Okay. Any other question? Okay. Okay, then once let's say the two things, tools and memory, get updated, means once it will take 2 class to uh, talk about tools and memory. Then after that, we can create a chatbot which having memory, and we will try to add functionality. So there are different in RAG also there are different types of RAG, right? Agentic RAG, and there are so once we learn this thing, then it will be much easier to uh, add those functionality into our chatbot, and suddenly the chatbot become powerful. Okay, and slowly you will see the uh, power of agentic AI. Okay, so yeah, that's it for today's class. Thanks everyone.
Thank you, sir.
Yeah.
Thank you.